Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about complex queries in SQL. The complex query starts from the subqueries with from clause, even select clause and with clause in it. And also we will discuss about the scalar subqueries. We will start with the complex queries of where the subquery starts within the from clause. That means whenever the from comes, we know that we are selecting a table or a relation from which the relation's attributes is getting to be fetched. So if we are putting a query inside a from, that means we have to select some relation first and then use that relation as a reference to get some attributes out of it. So we will see that how to do it. We will solve a problem that we want to get the average salary of each of the department in a computer science university so that we can get the average salary is greater than 42,000. So if a department's average salary is greater than 42,000, we will fetch the department name and the average salary of that particular relation. So for that, we are first selecting the average salary and department name from a relation which is based on the grouping by. Say the group by can be done in the outer query too, but it is being done more precisely if we put the subquery of selecting a relation from this from clause. Now inside the from clause, we are actually putting the department name, which will be same as the department name of the relation. Now we are calculating an aggregate function that is AVJ, which will give the average of the attribute salary, and we are aliases it or renaming it with AVJ salary. Now this from a department table or relation grouping by the department name. So first we have to group by the department name and then calculate the average salary of each of the department and then make it as a relation of department name AVJ salary. Now from that relation, we will select the department name and AVJ salary where the average salary is greater than 42,000. Now by putting this subquery inside the from clause, makes us the relation very short so that we can choose only the desired data with some of the predicates that will work only some of the attributes on the shorted down relation. So the main use of this subquery or the complex query with the from clause is to short the relation down so that the comparison time is shorter than to search in the big relation and perform the calculation. Say if this was not done in this from clause, then we have to group by the department name in an relation department which may or may not consist of 5 or 6 attributes. Now all the salaries and the department salaries will average first calculated, and then we need to perform this greater than comparison on average salary that is greater than 42,000. Now by shorting it down, we are making it only two attribute, that is department name and average salary. First calculating the average salary, then putting it down in a relation. Now selecting these two attributes depending on a predicate. So that is the main use of a complex subquery within a from clause. Now we will see some more examples that will support our answers. See here, we haven't used the having clause in the group by section of the subquery inside the from clause. because it is not mandatory or not necessary to use more than one clause if it is not needed absolutely. So here we can use that as a where predicate of the outer query, which is indeed natural than using a having clause of a group by query inside a subquery. If it is a complex query, it doesn't mean that we have to make it more complex to get it actually simplified. We can make it more simplified by putting this where clause where it can be put as a natural one. That is why we are not using the having clause here, only putting the predicate average salary greater than 42,000 inside the where clause, not in the having clause. Now we can do something interesting to it. We can rename this relation, that department name and average salary, and then use that relation as a reference to the outer query. Look for what are the changes I have made in the second query. In the second query, I have renamed this subquery as an department average, which consists of two attributes, department name and AVJ salary, so that we can reference this table or relation a later time also, not only on this query. So a subquery can be kept in another relation if we rename or aliases it with other relation. Otherwise, it will be reference for the outer query of that particular query only, so that we can use this department average later in any of the relation for reference. Now say on this department, on performing the average salary, we have to check that what is the maximum salary on each of the department. So as we know, we can again do it by the group by and having clause, but we will do it within a from clause subquery, making it a complex query but making the work actually simple. Now we will see that what are other variations of making this complex query. See here, I want to find the department total first, salaries basis, and then to find the maximum department average salary or the sum salary. So now we will look at that. Total salary, the attribute name that we are using for finding the maximum salary using the aggregate function max. But here I am not using any total salary while doing the subquery. I am only getting the department name and using the average function of sum salary here from the department relation. Now the aggregate sum salary is not mentioned as total salary inside the select statement of the inner query. But when I am renaming the inner query relation as the department total, here I am referring this department name as department name and sum salary as tot sal, which I am using it in the outer query attribute name. So either we can make it like the previous one inside the inner query, or we can just do it while renaming the relation and perform the attribute renaming so that we can use the renamed attribute in the outer query. Next, we will move to sum-like relation of this with clause, which is known as a predefined relation. Say it is a temporary relation that can only be used only the query on which it is being mentioned. Say on this from clause, when I am mentioning the subqueries and renaming it as an aliases, we can use that aliases in any other query, as it is taking a memory in the database and making actually a relation out of this in the database. But if I am doing this within with clause, then the relation will not be consisted in the database and only be used only that query that it is being mentioned. So we will see that how to do it with the with clause. Look for the key areas that I have changed with the from subqueries within a with clause. With a with clause, we are first writing the word with, and then we are renaming the table name or the relation name max budget with an attribute value here, which will I'll select as the subquery select max budget from department. Now the aggregate function max on performed by budget attribute from the department relation will be taken as a relation on which the max budget relation will be built, and the value is the attribute name of this maximum budget. Now we have to check that when I'm renaming it with a with clause, this relation actually doesn't take any memory in the database. It is used only for purpose solving on this query. Now, when I'm selecting the budget from department and max budget, where the max budget value is equals to the department budget. That is why I am finding the maximum budget in a department. So the with clause preferences is for that the queries will solve on a relation reference of a subquery, but it will not be stored in the database itself. Now, the main use of with clause lies within where we are using this for a complex query. See, this is very simple query and we can use this shorter subquery inside a from clause too. But say if we want to find that the greater or the greatest of the total salary of department whose salary is greater than the average salary of all the departments, then we have to make it within with clause where we need two aggregate functions and two relations and compare their salary result on the aggregate function max, sum and average, and then we had to select the actual result. We will see that how to do that. Now see here I am using two with clause and join them by separated comma. Now with the first use of the with clause in this table is to find the department total. That we need to salary and sum it department wise. Now department total is my relation name for this temporary purpose where the attributes are department name and value. And department name is same as the department name and value is considered as the summation of salaries grouped by department name, that is the department's summation of salary. Now I am checking this as well as by this comma I am telling the execution of query machine that there is one more relation that is to be within this outer query, and that is also a part of this with clause. Now when I am putting this comma and again mentioning another relation name, that is also a temporary relation being referenced for the outer query solving. Now what is the table? That is a department total average, which has a attribute value which is taken considered as the average value from the department total. See the interesting part here. First we have made the department total, and then I am using the department total within the with clause of another part, the department total relation. So we can do that also, that we are using the already mentioned temporary relation to create another temporary relation. So the department total average is considered to be the average salary of the department total that we have already been defined. Now using this department total average and department total, we can actually find the department name on which the department total averages value is greater than the average value of any department total. So we are getting the highest average salary of the department whose value is greater than any of the department's average salary. So we are using here these two relations which are temporary to the with clause and only to this outer query. So that are the use of the with clause, that making a temporary relation, using the temporary relation solving for the outer query, also using the temporary relation to create another temporary relation. Next we will move to the scalar subqueries. When I am talking about scalar subqueries, the main concern is to use a subquery or a complex query inside the select statement. That means I am selecting a relation out of another relation. That means I am scaling it down. I am actually scaling the relation into a shorter one so that the relation itself is the result of the final relation. So let's see that how to do that. Say for example, if I want to get the department along with the number of instructors in each of the department. So first one is easiest one, that I just want to fetch the department name from the department. That is the part of the outer query as a simple one. Now to get the number of instructors in each of the department, we need to calculate it and solve it as a subquery. See, I am performing the aggregate function count on all the records on the department and instructor relation where the department name is same as the department name of the instructor. So if the instructor is from physics and the physics is the department that I am counting on, so it will be counted 1 plus to the instructor name of that department. So actually I am getting all the instructors in each of the department, and I am naming this relation as a num instructors. So we can also rename a relation inside a subquery using in a select clause. Now when I am using that in a select clause, I am naming it and it becomes a part of the outer query, this renaming or the aliases. So it will give the department name along with the number of instructors in each of the department. The main thing to see here is that I am using a query inside a select statement, that is making the actual department relation, shorting it down by department num instructors, counting the department instructors, and putting it down as a part of the select statement to use it as a part of the relation. So if the resultant relation consisting of department name and num instructors, so the num instructor itself is not a value but a relation. But when I am using this, we must say that it must consist the exact same number of attribute that I am selecting from here and naming it only as a single one. So a single select statement in a subquery inside a select statement has only a single value in that relation. We need to keep in mind when I am using the select query of the complex one. So now we'll solve another problem of using the select clause, where we will use the select, where, group by and having together to make it complex and see all the different cases that we can use within the with clause, select clause subqueries, even in a from clause subqueries. Now look at this query. We need to select the department names whose salary is greater than 24,000, and then out of the department we need to select the department name who starts from P, that is physics or any other psychology, any other P starting subjects, and then we are selecting the department name and counting the department name's number. So what we are doing, we are first selecting the department name and the count distinct department name that will not be considered twice repeatedly. So grouping bound department name having the department name like P percentile. Now what is the main relation we are using? As department P name, from the department relation will be configured as the average salary 24,000 greater than, and we are referencing this one as a reference department relation. So we are putting the group by having clause, where clause, with clause in a single query. So this is the form of a complex subqueries. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.